Okay, let's dive into scatter plots. So in the previous examples, the box plot and the dynamite plot, adding a scatter of the data or plotting the data itself was the main way that we were able to improve the plot so that you could actually see the data points themselves. And that's what a scatter plot really does. So here's an example of a scatter plot. In most cases, scatter plots are displaying two variables, with one along the x-axis, or that horizontal axis, and one along the y-axis, or that vertical axis. And both of these variables are going to be continuous. And so the main purpose of a scatter plot is often to show the relationship between two variables. So let's discuss some common relationships that you might see displayed in a scatter plot when you're going through the medical literature. The first is known as a positive relationship. And sometimes this is known as positive correlation, since the two variables being plotted are positively correlated with one another. And so this means as the variable that's along the x-axis increases, so does the variable along the y-axis. So here we've got a positively correlated or a positive relationship between these two variables. Similarly, variables can have a negative relationship or be negatively correlated. And so in this case, as the y-axis increases, the x-axis increases, the y-axis actually decreases. So again, the x-axis is increasing, the y-axis is decreasing. And so in this case, these two variables have a negative relationship where they're negatively correlated. Variables can also have a nonlinear relationship. So for example, here the two variables are related via a U-shape. And when variables have a nonlinear relationship, it can be especially important to see them plotted, because this type of relationship can sometimes be masked by summary measures. For example, if we were just looking at the correlation between these two variables, we might not actually notice at all that there's a real relationship here. It's just not a linear relationship. And finally, it's also possible for two variables to not have a relationship at all. And so in other words, these two variables are totally uncorrelated. And in this case, a scatter plot will often just look like a large cloud with no clear pattern. All right, scatter plot pitfalls. So the main potential pitfall for a scatter plot is really the scale, which we talked about a little bit in that very first section when I was showing the best practices for creating statistical graphics. And so here's that example again, where I've added the y-axis to this plot. And notice the range here is from 0 to 160. And so I can plot this exact same data, but with a different range. And now the y-axis goes from 0 to 5,000. And see how it distorts the shape of the data. It makes it look like there's a totally different relationship. In fact, it looks like there's almost no relationship because I've stretched out that y-axis so much. So you want to keep this in mind when you see these types of plots in the wild. All right, so here's an example from the literature. In this study, this is one we've seen previously. So here, this is an alcohol control policy example. We're looking at comparing the alcohol control policies in 30 countries. And this study included a scatter plot where each point corresponded to a different country. So on the x-axis, the plot is measuring the alcohol policy scored for each country. And then on the y-axis, it's measuring the liters of ethanol consumed per person per year for each country. And so from this plot, we can glean that there's a negative relationship between the alcohol policy score and the annual per capita alcohol consumption. And so basically, as that alcohol score increases, the annual per capita consumption decreases.